Welcome back to another day of geometry. Today is going to be a rather brief lesson. And what we're going to do is just read this first heading right here. It says in lesson 6.1.1 you identified congruent triangles by looking for similarity and a common side length ratio of 1. So yesterday we said, hey, something's congruent if it is similar with a ratio of 1 between all of the corresponding sides. However, do you need to go through that two-step process every single time, or are there shortcuts for establishing triangle congruence? And the answer to that is yes, there are. Now, just as a brief reminder, we have shortcuts for similarity. We don't need to show all the angles are the same and all the side lengths are proportional. Now, for similar triangles, remember we had 3. Angle, angle, side, and side, side, side. So what I'm going to do today is just introduce to you not two, but actually a couple different ways that we can show the two triangles are congruent without going through that two-step process. So I'm on the next slide now, and what we want to do is I'm just going to go through and highlight these conditions that do work for us in order to justify congruence. And so the ones that do work for us would be side, 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 hypotenuse leg. Angle, angle, angle does not work. I'm going to do that one in red. Angle, angle, side, that is a congruence condition. Side, side, angle is not a congruence condition. Angle, side, angle is a congruence condition. One that they do not have listed there that we'll expound upon later as well, so I'll just make a complete list here of congruent triangle shortcuts. So just like what we had for similar triangles, we have some shortcuts in order to justify whether or not two triangles are congruent to one another. So what we have is side, 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 which again would be if you have two sets of triangles and you know that there are 3 sets of corresponding sides within all of the triangles, or the two triangles, something like that. The one that they did not list would be side, angle, side. And this is very similar to that in which we had with similar triangles. It looks something like this, where we have 2 sets of sides and the angle in between it being congruent to one another. We have angle, side, angle, which is another congruence condition shortcut. That's where you have an angle. I'll do this in blue. An angle, the side length in between, and another angle. Notice I'm using 2 tick marks for that one. And that same piece of information repeated again in another triangle. So angle, side, angle. Then we also have angle, angle, side, and angle, angle, side. Uses 2 triangles. It kind of looks similar to the one up above, but angle side is where you have 2 sets of angles, and the side length that you know that is congruent between the 2 triangles is not located in between the 2 angles. So it's located outside of the 2 triangles. And then lastly, the last one is what we call hypotenuse leg, and this only works for right triangles. So this is like the only caveat for right triangles, when you have a triangle and it's a right angle and you know that you have the hypotenuse of the triangle being congruent in each of them and one of the legs being congruent in each of them. So these are the 5 congruent triangle shortcuts that we're going to use and apply onto the next slide. These ones right here, be leery of these 2. Angle, angle, angle does not work in order to justify the 2 triangles are congruent, nor does side, side, angle. So those 2 we do not want to use in order to justify congruence between 2 triangles. So the last thing that we're going to do today is look at this one. It says use your triangle congruence theorems to determine if the following pairs of triangles must be congruent. And so as I go through and I look at these problems, what I'm going to first do is just again list off the ones that we have. We have side, side, side. We have side, angle, side. We have angle, angle, side. We have angle, side, angle. And lastly, we have hypotenuse leg. And so what I do to start with, when I look at a triangle and the set of given information, I first recognize that I have an angle here and another angle that are equal to each other. Then I have 2 sets of sides, this set of sides, and then another set of sides. So given this information, I have a side, and an angle in between. a side, and an angle in between. So that means that these two triangles must be congruent by side, angle, side. That would be the reasoning that I would have for that. Now in this problem, hopefully we can recognize that we have three sets of sides on letter B that are all equal, 31 and 31, 42 and 42, and 40 and 40. So those two triangles are the exact same. They are congruent. And the way I know that is through the side, side, side shortcut. I do not need any angles. Side, side, side says if you have three sets of sides that are equal, then we know that the triangles must be congruent to one another. Now, letter C is kind of a tricky one. If you take a look at letter C, here we have a side, another side, and an angle. And notice that the angle is located in between the two sides. In this triangle right here, these two sides and the angle that we have, the angle is not located in between the two side lengths that we know to be congruent like we do in the other triangle. So in this problem, we would say not enough information, as the set of information that we are given is not complete. They could be congruent, but I don't have enough info to draw a conclusion from that. Now, remember, in letter D, these two arrows mean that those are parallel, not that they are equal. The two arrows opposite each other means parallel, and I can't spell parallel to save my life. Parallel, and this goes way back to something we did in chapter 2. If you have parallel lines, remember that means that alternate interior angles are equal. Okay, not only that, but I could also say these angles are equal right here. And as such, I have an angle, another angle, and this side length of 6. I have an angle, and another side length of 6 here. So those two triangles are congruent by angle, angle, side. And it might not be evident at first because the fact that we were only given two sets of sides, but we can infer based off the parallel lines that those triangles must be congruent. Now this one, this is a classic one where two triangles share a side. Remember that that's going to be the same measure in both triangles, so that side length is the same to both. And again, here we have a set of parallel sides. Remember, that does not mean they're equal, but they are parallel. And if we have parallel sides, that means that we have alternate interior angles, again, being equal to one another. Two sets of angles are on other opposite sides of my transversal. So now, with my given information, I have an angle, and a side. And in the other triangle, I have an angle, and the side not included between it. So again, these triangles are congruent by angle, angle, side, which is kind of cool. This one, hopefully you can recognize that in the two triangles, they share this side length that goes down the middle, so that's going to be the same distance between both triangles. So I'm going to put 3 tick marks to signify that that's shared by both of them. I have 3 sets of sides, and so therefore that would be side, 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 justifying that those triangles are congruent to one another. Letter G, this is one that trips students up quite a bit. Notice how you have 3 sets of angles. Angle, angle, angle does not work. That is not a congruence condition. So here we would say this is not enough info. So you would need more information in order to justify that those two triangles are congruent. Angle, angle, angle is not a congruence shortcut. We need some kind of side length in there in order to justify congruence. And lastly, here again we have triangles that share a common side length. So I'm going to put a tick mark in here signifying that that is the same. So as I go through, I have a side, and an angle. And in the other triangle, I have a side, this shared side, and another angle. And notice how the angle is not in between the two side lengths. I cannot write side, angle, side like that. The angle is not located right here in between the two side lengths that I am given. So this is actually a side-side angle relationship where the angle is not included in between the two sides. And this does not work either. This is not one of the congruence conditions. So here we would have to say, based on the given information, there's not enough info in order to determine congruence. I know this can kind of be a lot of information at first, but we'll move more with it starting tomorrow as well. But just introducing to us these 5. These are the things that we should throw down, that we should know, how we can justify congruence between 2 triangles using these shortcuts. If you have any questions, feel free to stop by the office hours, and we will stay in touch.